Good morning, students. Today we are going to discuss about the sterilization of fermenter, air supply, and the media, exhaust air, and its kinetics. So first, move on to what is meant by sterilization. So, sterilization means nothing but if a fermenter having the fermenter having a nutrient medium and a culture, culture of certain organism, have to sterilize the nutrient medium before we have to use to the fermentation, right? So the sterilization is nothing but you have to first sterilize the medium before using some fermentation system. So while using the fermentation, when you not sterilize properly to the medium content means some foreign microorganism entry into the fermentation system, right? So the fermentation system, how the foreign microorganism enter into the system, we don't know, because there are so many various ways are entering into the foreign microorganism. So one is without proper sterilization, and some of the systems during a year without proper sterilizing air, the foreign microorganism enter. Once the foreign microorganism enter into the fermentation, what are the fermentation product now happens? First one is the medium. The medium doesn't know whether it is a that is a foreign microorganism or our microorganism. The medium doesn't know. So the medium property is to utilize the microorganism can utilize the medium. Our microorganism also utilizes that medium. Foreign microorganism enter into the fermentation. No, that is also utilizes the medium. So automatically the loss of productivity will happens, right? The loss of productivity will happen because of the foreign microorganism entering to the system. The foreign microorganism will have entry into the fermentation. The medium will also taken our foreign microorganism, and it will result in loss of productivity. Second one is if the fermentation is a continuous system. The fermentation is a batch fermentation, continuous fermentation. There are so many types of fermentation. Here, the fermentation is a continuous system means the contaminant will outflow the system. So some of the contaminants will outflow the system while the fermentation is continuous mode. The third one is the foreign microorganism contaminate the final product. You see, in the fermentation, you have a medium and also the microorganism, that is our microorganism, and also the foreign microorganism. But the foreign microorganism also utilizes the medium and produces the product. That final product will contaminate our product. Okay, so that is the main drawback. Fourth one is the contaminant produces a compounds. So some contaminants produces here compounds. That extraction of the final product, if you extract the final product by using a downstream processing recovery through filtration, centrifugation, separation, so the extraction of the final product is difficult because the contaminant produces here compounds. The next one is the contaminant degraded the desired product, right? So the contaminants means sometimes the contaminants also degraded the desired product. If our product is say I want a methane as a product, but the methane will degrade our contaminants. That is a foreign microorganism contaminate the methane product. So like that the contaminants degraded the desired product. The next one is the contamination of bacteria. If your fermentation having a bacterial contamination means the bacterial contamination will mix up with the phages which results in lysis of the culture. So these are the following consequences will occur when the foreign microorganism enter into the fermentation. Okay, so what are the consequences occurs? The medium supports the growth of the product organisms and contaminants results loss of productivity. And the second one is the fermentation is continuous ones means it will contaminate outflow the system. And the third one is fermentation, that is a microorganism will contaminate the final product. Fourth one is the contaminant produces the compounds, that is the extraction of the final product is difficult because the contaminant produces the compounds. So and for fifth one is the contaminant degraded the desired product. The final one is the contaminants having a bacterial contamination means it will mix with the phage lysis and results in lysis of culture. So how to avoid this contamination? So next step is okay, if the contaminants in the foreign microorganism enter into the fermentation means How to avoid the contamination? The first and foremost one is you have to start the fermentation. Before you have to start the fermentation, the inoculant should be a pure one. Right? The next one is medium. You have to sterilize the medium. Whatever the medium used in your fermentation, you have to sterilize it. The next one is whatever the vessels used in the fermentation vessels, say the bioreactors or in the materials used in the fermentation, all should be sterilized. And the fourth one is maintain a aseptic condition during a fermentation. Okay, whether you have just sterilized all those things, okay, then only you have to start the fermentation. So these are the avoidance of contamination. So what are the sterilization methods are followed till date? So first one is the heat sterilization. The most and widely used sterilization technique is heat sterilization. So the second one is the quality and the quantity of the contamination, the composition of the media, pH, size of the particles, that all influences the success of the heat sterilization. The heat sterilization means it will just what are the type of the microorganism presence, what are the load of the microorganism presence, what are the composition of the media, what is the pH, like that. So the heat sterilization in the quality and the quantity of the contamination, the composition of the medium, pH and the size of the particles, that influences the success of your heat sterilization. The third point is there are two cells are active. The first one is the vegetative cells and another one is the spores. So you see the vegetative cells are destroyed at very low temperature in a short time. Okay, it requires only a short time. In a low temperature, the vegetative cells are destroyed. Say what the temperature it needs is only 60 degrees Celsius, and the minimum time 10 minutes is required to destroy your vegetative cells. But in the case of spores, what is the spores destruction means, it requires some higher temperature and it requires a longer time. Okay, so what are the temperature? The 80 degrees Celsius. You see the comparison. In the vegetative cells requires only 60 degrees Celsius, but in the case of the destruction of spores, we requires a 80 degrees Celsius. And the time also it will be a little bit higher when compared to the vegetative cells. In the destruction of spores requires 20 minutes to destroy the spores. The spores is, for the example, Bacillus stereothermophilus is used because it is the most heat resistant. So this organism is used as the sample for the fermentation. Okay. When you compare the all other organisms, this is the most heat resistant. So this is to be used as the one of the sample of your fermentation. So these are the heat sterilization. So heat sterilization is nothing but it is most widely used. How the heat sterilization occurs means what are the heat sterilization is? Medial composition, pH, size of the particles, quality, quantity of the contamination, all will depends upon the success of your heat sterilization. And the third one is there are two types. One is vegetative cells, one is spores. In the vegetative cells requires a lower temperatures, 5 to 10 minutes, 60 degrees Celsius at 10 minutes temperature is required. But for the destruction of spores, it requires a higher temperature, say 80 degrees Celsius for 20 minutes. So Bacillus stereothermophilus is the organism which is mostly used because it is a heat resistant one. Okay, the next method of sterilization is the physical method of sterilization. There are so many physical methods. The first one is filtration, centrifugation, or adsorptions, all are used. So the filtration is mainly used. Why the filtration is used means some of the products, that is a medium, while using in a fermentation, which will not withstand the heat. Okay, so it will easily degrade the particular compound or the medium. So for that filtration is used because heat liable compounds are mostly used by filtration technique only. So what are the heat liable compounds means? Vitamins, blood components, antibiotics, or the culture medias were used, that is our heat liable. So they are destroyed by heat sterilization. So we go for those contents by using a filtration technique. So the next one is, there are two types of sterilization. One is batch sterilization and one is continuous sterilization. What is meant by batch sterilization? So the culture media are subjected to the sterilization at 121 degrees Celsius in your batch volumes. That is for you are we are using an autoclave now, the temperature is what? 121 degrees Celsius. Minimum 20 minutes is required, and the PSI is 50. PSI is used to sterilize the medium content. The same temperature is used for the batch sterilization. So batch sterilization can be done by injecting. There is the two types. One is the direct method and another is indirect method. The first one is direct method, is injecting the steam into the medium. The second one is inject the steam into the interior coil. So these are the two types. And the next one is, what are the, for the direct batch sterilization, the steam should be pure and free from all chemical additives. Okay, so this is the mainly used. So what batch sterilization 121 degrees Celsius, and they can be injected in two methods. One is direct method and one is indirect method. Direct method is injecting the steam into the medium. Indirect method is injecting the steam into the interior coils. Okay, there are two disadvantages of batch sterilization. What are the disadvantages? First one, it will damage the culture media. Okay, so how the damage will occur means, it will alter the nutrients, change in pH, discoloration of the culture media. These are the some causes occurs while in culture media. Okay, so first one is first disadvantage is it damage the culture media in related to nutrients alterations, pH changes, discoloration of the medium. This will occur. The next one is high energy consumption. You see, minimum temperature requires 121 degrees Celsius, and also time is also, it takes 2 to 4 hours requires to achieve this 121 degrees Celsius. After that only the sterilization occurs. Then sudden cooling will not occur. Okay, the step by step cooling is only occur. So it will took only 60 minutes. Okay, it will took 60 minutes to cool step by step from 121 degrees Celsius to 0 degrees Celsius. So, hardly it takes 2 to 3 hours to complete the one batch of sterilization. So it requires a high energy consumptions. So we go for the continuous sterilization. Okay, these are some disadvantages of batch sterilization. First one is damage the culture media, high energy consumption. So we go for the continuous sterilization. Continuous sterilization is carried out to 140 degrees Celsius. Here the temperature is high, but you see the very only short period of time is required to carry out this temperature. That is, continuous sterilization is carried out to 144 degrees Celsius for a very short period ranging from 30 to 120 seconds. Okay, so you see 120 seconds is only requires to reach the temperature 140 degree Celsius. So this is based on the principle time required for killing the microorganism in very shorter at higher temperature, shorter time at higher temperatures. So there are also two ways, is carried out by directly injecting the steam or by means of a heat exchangers. So you see the heat exchangers means there are three types of heat exchangers. So first heat exchanger, what it will do means, first the temperature is rises 90 to 120 degrees Celsius. First heat exchanger temperature rises within 20 to 30 seconds. And the second exchanger further rises the temperature to 140 degrees Celsius and maintains here 30 to 120 seconds. The third heat exchanger, it's bring down the temperature by cooling to next 20 to 30 seconds. So in the continuous sterilization, three types of heat exchangers are used. The first heat exchanger is requires 120 degrees Celsius within 30 seconds. Second exchanger is further, it will rises the temperature to 140 degrees Celsius and maintains for 120 seconds. Third heat exchanger, it will cooling heat exchanger, that is bring down the temperature by cooling in the next 30 seconds. So the actual time required for the sterilization is depends on the size of your suspended particles. Whether the bigger size means the more time is required to sterilize your content. So the size is very important while sterilizing the content. So the main advantage for the continuous sterilization is here 80 to 90% of the energy is conserved. So you go for the continuous sterilization. Its main limitation is here you see some certain compounds present in the media get precipitated. For example, if your medium containing a starch means it becomes viscous in the continuous sterilization. So this is the main limitations for the continuous sterilization. So next you see the picture here in the continuous sterilization, the steam is injected in the outflow of your pipe, the medium is introduced into the pipe, there is some folding section and expansion valve. From the vacuum flash chamber, the sterile medium is out. Okay, so steam is injected into the tubes. So the mediums are flows into the tubes, the steam will sterilizes the medium and outflow your sterile medium, you get into the continuous sterilization. There are some different stages in the continuous sterilization, difference that is related to temperatures. What are the stages means? Exchanger, heater, heat maintenance unit, recovery of the residual heat, cooler, fermenter. These are the some of the stages in relations to temperature. The next go for the sterilization of media. How to sterilize the medium? So the constitutions of the culture media, water, containers contributes to the contaminations by vegetative cells and spores, right? Whatever the media, water containers, all that contributes the contamination by vegetative cells and spores only. The medium must be free from contamination before use in fermentation. So the sterilization media is applied by heat and the lesser extent by some of the physical methods, chemical treatments or radiation or filtration, like that you have to sterilize your content. The next one is the sterilization of the fermenter. Not only what are the medium used in the fermenter. The fermenter itself we have to sterilize. Okay. The fermenter is also, there is two types. One is in situ, another one is ex situ. In situ means within the fermenter. Okay. The fermenter will be placed within the system. Within the system, the fermenter is sterilized. Ex situ means you have to take out the fermenter out and sterilize the fermenter. Then you have to go for the fermentation. Okay, in situ means inside, ex situ means outside. Okay, so these are the two types. So if you sterilize the fermenter means you first check whether the steam is introduced into the fermenter coils or a jacket, like that. Whether the entry point and exit point of your fermenter, no, there will be no any contaminations are present, because the steam should be freely introduced into the entry and exit point. If they are present, some contaminants or some sources are present in the entry particular coils, means definitely the steam will not enter into the system. So you have to whether check out the entry points and exit points are very clear when entered into the steam. So the steam should be passed on to the entry and exit stream. And also the pipes also, should be very simple construction only, and slope towards the drainage point, like that. The drainage points is like slope mode, like that. Entry and exit point is very important, because the steam should be easily flow into the pipes. Okay, but if the pipes will have some sources of contaminants or some viable cells are to be present in block the pipes, means the steam will not enter into the system. So you have to whether check out while introducing the steam. So for this this is the sterilization of the fermenter. Another one is filter sterilization of air. How the air is also to be sterilized, right? Why the air is to be sterilized means, in the case of aerobic fermentation, the oxygen is required for the cells. Okay, so for that the air is to be introduced into the fermentation system. So that air is to be pure. If it is unpure means, definitely the contaminants introduced into the fermentation, and it will result the loss of the productivity. So the air sterilization is mainly required for the aerobic fermentation. How to sterilize the air means, mainly used air sterilizer, fixed pore filter is used for the air sterilization. So for sterilization of liquids means PTFE, some PTFE pleated membranes having a supported of PTFE membranes, that is to be steam sterilized. Then the particular air is to be sterilized. First the pre-filter is sterilized, then and then only the air is to be introduced to be sterilized. Next one is exhaust gas. So okay, the fermenter is get running, and some oxygens, pH all to be checked, and finally some gas is also coming out of the fermenter, that is also to be sterilized, because for the some products, that is recombinant products, if we are using a recombinant products in the fermentation means, for that condition the gases should also be sterilized. So for the outlet pipe, we have to use the 0.2 micrometer filters are used to filter the moisture, solid matter, like that. There are two types, that is cyclone separator and the coalescing filter for your liquids. These two are used to sterilizes your exhaust gas from the fermenter, to ensure that is no viable cells are escaping from the, okay, because the exhaust gas means some viable cells also escaping from the fermenter. So we have to check whether there is no viable cells is released from the fermenter. Okay. The next one is last and final topic is sterilization kinetics. So here the kinetics is mainly deal with if the medium is having a microorganism, the microorganism or a contaminants microorganism presence, how much the contaminants will clear out from the fermentation. That is to be described in your sterilization kinetics. So first one, the thermal death of the microorganism at a particular temperature. At a particular temperature, say for the batch sterilization means it's 121 degrees Celsius. For continuous sterilization means it is 140 degrees Celsius. So at a particular temperature, the microorganism death, the thermal death rate can be calculated by the first order kinetics, that is minus dN by dt is equal to Kd into N. Kd is the specific death rate, N is the number of organisms present after the sterilization kinetics. So Kd is the specific death rate. So here the NT, we have to integrate this dN by dt is equal to kdn. We get a NT is equal to N naught e power minus kdt. N naught is the number of viable organism onset of the sterilization. Okay, before starting the sterilization, what are the organisms present? That is N naught. NT is after sterilization, what are the organisms present? That is the NT. So after that we have to logarithm, taking a natural logarithm on both the sides, we get ln NT by N naught is equal to minus Kd into T, which shows the exponential decay of the cell population. From this it will relate the Arrhenius equation, that is Kd is equal to K naught into e power minus Ea by RT. So the slope here is minus minus Kd. Then we have to plot a graph, that is ln NT by N naught divided by that is versus x-axis in your time. We get a most increasing temperature. T1 here is 105 degrees Celsius, T4 is 121 degrees Celsius. With the increasing temperature, what is the specific death rate? From the slope we have to calculate the specific death rate from the graph. This is the loss of cell viability at various temperatures. The graph which indicates us the loss of cell viability at various temperatures. So here the main 2-mark question is design criterion, that is death rate criterion or design criterion, del factor, nabla factor, that is del. Del is equal to what? There is a NT by N naught. Okay, ln N naught by NT is equal to del. So that is defined as a design criterion. What is mean by design criterion? Asking a 2-mark question. So ln N naught by NT, that is a del. Here N naught is the number of viable organisms present at the onset of the sterilization. NT is the number of organisms present after the sterilization. So that the equation, that the expression is named as del factor, nabla factor, or the design criterion. It can be called as in these three ways. Okay students, you all are well known about this now, the sterilization part. What just we reviewed once again. What are the, today we have discussed means the sterilization of fermenter. That's what is mean by sterilization. Okay, if the foreign microorganism entry into the fermentation, what are the consequences occurs in the fermentation system? Then how to avoid the contamination? Okay, then what are the types? That is heat sterilization, physical methods. These are some sterilization methods are used. Normally two types of sterilization. One is batch sterilization and then one is a continuous sterilization. Here the batch sterilization means two types are there, and also here disadvantages also we have to discuss some disadvantages like damaging the culture medium, high energy consumption it requires, like that. Then one is continuous sterilization. Continuous sterilization is mainly used for the energy conservation because it requires a very low time at higher temperatures, but batch sterilization requires a higher temperature but longer duration requires to sterilize your content. Then we have discussed some stages in a continuous sterilization, 3 stages. First heat exchanger, second heat exchanger, third exchangers, what order they do. The next one is sterilization of media, how to sterilize the medium. If there's a heat labile components means you go for the filter sterilization, like that. Then sterilization of fermenter. Fermenter, there are 2 types, one is in situ and another is ex situ. So how to sterilize is the entry and exit point of your fermenter. You have to check whether the cells or some contaminants are present to block the particular sample point or not. You have to check, then only you have to introduce the steam into the system. Then filter sterilization. Why you go for the filter sterilization of air means whether the fermentation is in aerobic fermentation means it requires air sterilization. So this is the main thing. And then one is the PTFE. That is the filter is content, filter content is PTFE. You have to sterilize the air before the pre-filter, you have to filterize, no? The pre-filter contains a PTFE membrane like that. Then once exhaust gas from the fermenter, some exhaust gas is released from the fermenter, that is also to be sterilized. There are two types, one is cyclone separator, another one is normal coil using filter. So then you have to sterilize as the fermenter. And last and final topic is sterilization kinetics. The sterilization kinetics, they mainly deal with the thermal death of the microorganism by first order kinetics. What is it? dN by dt is equal to kdn. So kd is the specific death rate. Then nt is equal to n0 e power minus kdt. So taking logarithm on both the sides, we get ln nt by n0 is equal to minus kd into t. So by Arrhenius equation, we get kd is equal to k0 e power minus e by rt. So by the graph, that is ln nt by n0 versus time t requires here different temperatures. From the temperatures, we have derived the slope. Slope that is nothing but minus kd. So the loss of cell viability at various temperatures can be calculated using this graph. After that, main what are the two marks? This is del factor, that is Debla factor, design criterion, that is ln n0 by nt. So n0 here is number of viable microorganisms present at the onset of sterilization. Nt is the number of organisms present after the sterilization. So that expression is called as a del factor. Okay. Okay, fine. You all understand these topics. So further topic I will be given in a future in your classes. Stay tuned, students, and stay home and safe home. Okay. Thank you, students.